I think we should probably get started. First, thank you everyone for joining us today. This is the start of what we hope is going to be a regular weekly series. And the idea here is that every few months we get one of these big events. We get like ZIO World, or we get like Functional Scala, and we get these presentations where people put in like a ton of effort into making these like really great presentations, which are awesome, but it means like takes a few months in between them because people have to do other things than making these presentations. And we heard a desire from all of you that you wanted kind of more ZIO content and content that was in between those big events. And so that's really the idea of these sessions, is to be something that's a little more informal, a little bit less prepared, where we're going to have something to talk about, but it may have bugs. We may be working through things. Sometimes it may be really interesting. Sometimes it may be kind of banging your heads against the wall, figuring out something, but that we'll all have a chance to get together and kind of learn together and figure out things and all build our knowledge here. I think Kit's been fantastic at, I think he's one of the best presenters we have probably. I mean, he's done, I feel like his presentations always put the rest of us to shame, and kind of does a great job at explaining things. So he's been great at kind of spearheading this, and really excited to be with him today to start this off with all of you.
Yeah, thanks, Adam. That is too kind. But yeah, no, it's just fun to talk to people, and it's fun to talk about ZIO. I like it a lot. It made me like Scala. It made me like Scala more than Haskell, which I didn't think was going to be possible when I started out. But yeah, let's get into what we're talking about today, which is building an actual app with ZIO. And so if anyone saw my talk at Functional Scala 2020, I did a little thing on Scala.js and ZIO. And it went all very well in the first 5 or so minutes. There was an interactive portion to it. People could vote for different letters and spell something Ouija style, form of muted communication. And it worked quite well for a moment until it then crashed. And I had to switch over to a local copy, and it all still went all right. But it was slightly mortifying at the time. But you have to decide, do I start breaking down and crying right now, or do I just pretend everything is okay and keep going? And I chose to do the latter, and it worked out nicely. However, it would be great if future talks did not crash and would be resilient. And Adam has been doing some very cool work lately, which I think just got merged into ZIO Master, which is going to be available for ZIO 1.0 and 2.0, which is this thing called a Z Hub, which is basically ideal for my use case, which was broadcasting, accepting a bunch of WebSocket connections and broadcasting out a bunch of changes, to have this sort of interactive voting system in a slideshow app. And I thought, yes, this would be great. This will prevent further apps from exploding. So we tried to do that. And in fact, we just 5 minutes ago were able to connect the Z Hub to this thing.
Mainly because of issues with our publishing and not with, I think.
Yeah, not with Z Hub, with GitHub Actions that so a lot of things. But anyway, so that might add a flair of informality to this. But I'm going to share my screen, and I'm also going to post a link to this slideshow app, and we'll see if this doesn't explode with everyone. If it does, okay, well, to learn some lessons in the next week, we'll share what those lessons are, and I can at least just show off the code locally. But I really hope it doesn't explode. So let's see what happens. So I'm going to go over to Discord and post a link to zioslides.surge.sh, and we'll see what happens. Hopefully, everyone is able to see this page right now. Adam, if you can maybe man the Discord terminal and let me know if people are screaming it.
I can see it. I don't think we have the most active group yet. Oh, yep. All right. Fellow says it works.
Okay, so here's the real test of whether or not it works. I will now advance the slide. Today we're going to build a ZIO backend. Does everyone see that?
Yeah.
Okay, you see it, Adam?
Mm-hmm.
Okay, lovely. For an interactive slideshow app, so very meta. Obviously, it's slightly built already. Otherwise, this wouldn't be working. The way this generally works is that there's some kind of slide state, which this is all on slide index 1. There are these two. There's these two properties. There's a a slide index, which is the current slide you're on. And then each slide itself has different steps. So step 0 is just here, step 1, step 2. So you can use these on the front end to sort of incrementally reveal content. And then if I go to the next slide, slide 2, lorem ipsum dolorem et, we can see that the content sort of deteriorates in quality into Latin. But here's the step I'm on. It's not being used to animate anything except for just showing the current step. Does everyone see lucky step 13?
13.
Okay, so that's one thing. The other thing we could do, I'm not sure which one I'm more scared to try, is what should we do, Adam? Should we do questions or should we do voting? Which one do you think is, what?
Let's do voting.
Okay, so this is what exploded everything last time, but everyone should be able to hover over things and then see, that's kind of your vote, should it happen immediately. And then I'm not seeing any numbers here, so I'm afraid that it exploded, but we'll see. I might have blown it up.
I'm still on the building a ZIO app page.
Oh, okay. Well, maybe that's the problem right there. Is everyone still on building a ZIO app page? So I might have actually blown it up. But no, I see a question came in, so that's interesting. I've blown something up. Does anyone see slide 2?
I'm still on building ZIO app.
Okay, I must have exploded something. So I'm stuck too. Okay, good. Let me see, there is a Q&A, nice. Let me go to, still on the first slide, okay. People have figured out how to ask questions though, and those aren't broken. So I'm going to go to Heroku log's tail and see why I can't go to a second slide, if there is anything. Not really, everything looks to be working. And what do you see on building a ZIO app? Do you see today we're gonna build a ZIO backend or anything like that?
I was just saying the very initial view.
Okay. Okay, so perhaps it didn't advance, which is interesting. I might have, yep, just see building a ZIO app. Okay, I might have exploded it, even though I am getting things. Okay, there we go. Do you see a question?
Yes.
Okay, yeah, the question feature apparently works. Apparently the question feature works. So I can field people's questions and post them here for the people who know how to ask questions. So at least that hasn't exploded. Well, no matters, we'll show off a simpler version that is not going to explode. So that's unfortunate that it exploded again. So as I said, more informal. Next week, we'll figure out why that has happened. In the background, I could try to deploy the last working version, but I have a local copy, so we could take a look at what should be happening, and then we could at least talk about the architecture, even though obviously it's slightly less exciting if it explodes. So I need to just go here and quit this Heroku tail logs thing, start it up locally, and there we go. So yes. So ideally, multiple people can be connected like this, and as I step through, everyone should be able to see the slides advance. People should be able to ask questions like, what is going on? These should appear to some admin who has the power to control this. So if this person maybe asks a question on slide 3, step 9, howdy. That's not a question. Howdy, question mark. Maybe I've screwed that up. Wait a second. I'm going to restart the backend. So they should all go back to the first page. Maybe I've introduced a bug with the questions actually. Hello, hello. Okay, there we go. Now we get some questions going. Okay, so the idea is, what is this? If I click on a question here, it will take you to the slide that the person asked that question on. So there's a little slide index down here. So what is this was asked on this slide. So I can control back to this beginning page. And if I select this question, it should be able to present to everyone the question that was asked in the context that the question was asked, which should be interesting. So it at least works locally. And then there's also this sort of voting system where each person should be able to hover over a different topic, and then that will show up on everyone else's pages. Obviously, there's a debounce here to hopefully prevent the server being overwhelmed, but everyone at least appears that they have a very responsive voting locally, but only once a sort of debounce delay is surpassed will that change get broadcast to everyone else. So if I vote over here, we'll see that it sort of shows a little crude bar graph of the percentage of the votes, so each person can manipulate that. Cool, so yeah, these each have 1/3 of the total votes. And you can move it around like such. Woo. Okay, so what I'm going to do is basically talk about, well, feel free to ask any questions. Obviously, it exploded in production, so I'm going to try to roll back a change I made literally 3 minutes before starting this in hopes that that will fix it, but it might not, which would be just undo, 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 and undo. And then I will, in the background, attempt to, once again, deploy this to Heroku. Hopefully, this works, I will say, and I will push it to Heroku Master. And while that's happening in the background, I will actually talk about how this is working locally in the happy version that works. So how is this stuff working? Well, there is a Scala.js front end and a Scala backend. So it's all Scala all of the time. The front end is communicating with the backend via a WebSocket connection, currently using HTTP 4S, and they broadcast messages back and forth. We'll take a look at those messages. The project has 3 pieces to it. There is a backend project, a front-end project, and then a shared project. And the shared project basically just contains the state that we want to have on both the front and back ends, as well as the protocols, which is these things called commands. So here, there are these client commands, and the client commands are the commands sent by the client to the server. So over WebSockets, the client can interact in these specific ways, which is an administrator. These can toggle between slides, toggle between steps, and then toggle questions. So given a questions UUID, it can toggle them on and off. So every time I say, if there's a question here, what is this? If I click on this, that's toggling the question. So that's sending a payload representing this case class serialized into JSON over to the backend as an admin command. And then users can both ask questions, so they can give a question string that has a particular slide index, which is the index of the slide they were on. So if a user asks a question on slide 2, step 10, it will then jump back to that slide whenever I present that question. So that we need that information, the context where the user was confused, which is theoretically a nice feature to have. So these are both these things called client commands. They both extend client commands. They're just nested sealed trait hierarchy. And then there's send votes as well, which contain a topic and then the actual vote that they made. So the topic for here is kind of hard coded. It's a string that represents, I think it's just today's topics in string form. And then every time a user hovers over one of these, and after the sort of the debounce time is exceeded, it's going to send the content of the individual vote to the backend, which is nice. And the backend knows the ID of the user and it uses all of that information, but we can get into that in a moment. And then there are server commands, which are the commands that the server will send back to the client. So that's we just took a look at the messages that the client sends to the server, and this is the messages that we send back, which is a new slide state, a new question state, and then chunks of votes. And the user's ID as well, which is a little bit of a hacky thing. So slide state is just this case class that has some helper methods on it, but at the end, it's quite simple. It's just an index for the current slide, and then a slide step map. So it's a map from slide index to the current step that slide is on, such that when I'm on, say, the slide 2, I can be on step 5, and then when I go back and forth, I'm still on step 5 for slide 2. So it's just a total bookkeeping of where you are. And the really nice thing about using Scala.js and Scala is that this case class is, and sorry for the cat trying to, I'm not sure if you can quite hear the yelling. It wants me to, I don't know, pet it. And I love the cat so much, but I've pet it all morning. So the slide state is, oh, cat. The slide states, so this can be used on both the front and back ends. And all of these helper methods can be used across the front and back ends as well. And let's see. So where is this happening? I've never heard my cat be so loud. My girlfriend's going for a walk, so it's very sad. Oh, cat. Maybe I'll get her and put her on my lap. One sec. Anyway, we said it's informal, so here's my scary cat. and she loves everyone. Her name is Worm. She's a beautiful little baby, and she loves Scala.js. And now she's gonna probably yell closer to me, but hopefully she won't. We'll see what happens. She loves attention, and it's very sweet. Okay, so these are sort of the case classes that we're dealing with, and they're very simple. It's as dumb as it can be, but it's serializable. I'm using ZIO JSON in order to serialize it back and forth. And yeah, it's nice because it can be shared by the front and the back end, such that when someone refreshes and rejoins, they get the current slide state sent to them. And then they also, every time a change happens, they get an updated version of the slide state. By the way, are there any questions that you see in the chat besides, is your cat okay?
Someone wants you to sing the song of your people. I told them that they had to wait for a later session for that.
The song of my people. Yes, that'll be next week. I'll have to figure out what that means, but then next week. Okay. Yes. So there are a few features I want to add to this app as well, but I think it's still worth probably digging into the architecture more. All of the front end code is about, it's basically all here, and it is 300 lines of code, which is not so bad for all the front end code for something that has, a few features in it, the question asking, the votes, etc., the WebSocket communication. So let's take a look at the sort of the high level of the front end code. It's all in one ugly file, but so be it. The core is this thing, which is, by the way, I should give some technologies we're using. I'm using a program called Laminar. So there's Laminar. That's actually really it. I'm using Laminar, and I'm using some extensions that were made for WebSocket communication, which gives a very nice WebSocket API here. So what I'm doing is I have this WebSocket, which is parameterized by two types, basically the messages received from the server and the messages sent to the server. So these are the server commands, and the client commands are going to be piped over this WebSocket connection, which is very nice. And then there's a ZIO JSON interpreter here that will just sort of work as long as there is a decoder and an encoder for these things, which I have made. A ZIO, I've derived a JSON codec for these, so this will all compile. And what that lets you do is WebSocket, this WS has a few different properties. Let's take a look at how I'm using it. So WebSocket.received, I think, is the more interesting one. So whenever the server sends us a message, we can just match on it. It's all automatically going to get deserialized, and then I can match on it. So it's very boring stuff is happening here. If the server sends us a new slide state, we're setting this local slide state var, which starts out as empty, to whatever the slide state is that the server sent us. Same with question state. We didn't look at the contents of that, but it's basically a list of all the questions and an ID for the active question, which is optional. And so we update that. Votes is a little bit different because I was trying to have it not blow things up, but it looks like things blowed up. Looks like things blowed up even before we got to votes. So I'm not sure exactly what exploded today. Hopefully next week I'll have a nice autopsy for everyone. But the idea was, what I thought was maybe the problem with the last attempt at this was, and it's kind of hard to get 100 people to show up, so thank you for all helping me load test this. What I thought was the problem was that a couple things. Every time, in the last version of this, every time someone hovered over, I did not have a debounce. So it immediately sent that command to the backend. And then on the backend, it would actually store these votes in a big nested map from topic. So because I want to have maybe multiple little polls like this around the slideshow. So this would just be one. It has the topic, and then inside of that, there's another map from user ID to the user ID's vote, so that it could be quickly updated. And basically, every time someone hovered over anything, so if you go from top to bottom, it would send 4 messages to the server, and then the server would broadcast the entire vote map to everyone, which was very stupid of me. I wasn't quite thinking. It worked when testing it with 10 people, but when it got to the 100 or so people of the presentation day, it quickly exploded. So I added some debouncing, and then I also, in order to anticipate the problem of broadcasting this increasing sized vote map to everyone, what is nice is that send votes is actually sending a chunk of these cast vote IDs, which could probably have a better name, but it's basically a user. It represents a user's vote for a particular topic. So it's just a series of events of this person voted for this vote under this topic. And then vote state has a function for processing chunks of votes. And really, vote state is this thing called just a wrapper of this thing called a vote map, which is just a map from a topic to a map of user ID to votes, which are just basically strings. So that's the vote map. But every time these votes are sent, the users will receive sort of batched up chunks of votes that are received from the user, and then it will process these locally. So it's kind of like it's not quite CRDTs, but it is kind of like an event-sourced model where you're folding over the events locally. And the really cool thing is this can be tested on the back end, but obviously, because of Scala.js, I mean, it's a pretty simple concept, is that this will just work both on the front end and back end. You can share the logic of updating these cast votes such that you broadcast out these events, and then the state can be the result of folding over the events over time. So every time on the server or the slides app in here, when we get votes, what I do is I take the vote state var, which is this functional reactive variable that holds on to first an empty vote state, which is just basically an empty map. And then it will call process updates on these votes, filtering out the user's current ID, which is nice. That's just a little extra detail. We don't really have to worry about that, but I didn't want the user's vote to, let me explain why that is the case. Okay, so let's see. So yes, basically the idea is that I want the user from the user's perspective, for it to feel very responsive. So you hover and immediately your vote is represented. But obviously it's debounced to everywhere else. If the client broadcasts the user's vote to the server, and then after a debounce, that server broadcasts it back to the client, there is a chance that when I hover over this vote, and then the debounce limit is reached, it'll send that vote out, this vote out, WebSocket communication out to the server, and then the user moves it down here, which will immediately update their vote map. But then the server sends back the vote that was just debounced, which will be this one. And so it will jump the user's vote back. And that was kind of ugly. So that's why there's this filtering out of the user's votes from these votes, because that's done on hover locally, which is nice. But ideally, this would really minimize the payload, because these are debounced and then the votes are aggregated into chunks on the back end using a very convenient ZIO streams API, which will aggregate all of the votes that the back end receives within a particular time frame and then broadcast those to everyone simultaneously. Okay, so that's kind of how we receive things. And then we should look at how we send events. So there are a couple ways of doing this. One is just send one. So I take the same WebSocket model, and then if I look at the type here, I can send any client command. So when an admin hits the arrow right key, I'm getting all the window events and getting the on key down. If an admin hits arrow right, it's going to simultaneously eagerly update the slide state var. So I don't have to wait for this to be, not that there's really any delay locally, but there would be if this were on Heroku. So I'm eagerly updating my slide state var, but then simultaneously broadcasting that same command to the backend, which is going to update its slide state, not a var at that point, but a sort of a ZIO ref, but the same idea, and then broadcast out that change to everyone. We'll see how that works. And same thing with these other commands. And that's basically how it all works. We respond to some commands, we respond to some user input, and then we send these commands to the backend. And we might also eagerly update the variable on the front end. So right now, the server is pretty simple. It's about 80 lines long. Most of that is this boilerplate for setting up an HTTP 4S server with ZIO interop. I always, for this boilerplate, check out the Caliban examples repo for Caliban, the GraphQL library. It has a great set of up-to-date examples for all sorts of different servers. And so there's generally a good idiomatic way of running a ZIO app for basically every potential Scala web server there. Turns out that's a solid up-to-date resource because it's kept up to date. It's a very active project. So I basically always consult that every time I need to make a new backend app. So this is just kind of boilerplate, nothing terribly interesting here. The interesting thing is this routes, which when a user connects over WebSockets, the way that HTTP4S has you set this up is you make a WebSocket builder that takes two parameters, or it takes multiple parameters, but the two important ones are a stream that you're going to send to the client and a stream for what to do when you receive events from the client. So the from client basically is going to accept a stream of these WebSocket frames, which are what WebSocket sends you. They're pretty low level, but really the only one we care about, what do they have? Well, it's an abstract class. The ones we really care about is text, which is going to be the JSONified version of our client commands. So those commands that are sent from the client. And all I do is call from JSON on ZIO JSON and then match on it. So if it's a left, I just print out, hey, there's a decoding error. And if it's succeeded, we take the command and then we call it, we call receive on this slide app thing, which is the ZIO service that basically handles all of the app's logic. And it sends the command along with the user's ID, which is a very silly little thing where this is basically a closure. when we first get that WebSocket connection, we just generate a random user ID and then sort of bind it closure style into the different methods that it cares about. So that's from clients. We'll take a look at the actual slide app where the interesting logic happens. But the slide app also has these methods on it that give you different streams. So there's the slide state stream. There's the question state stream. There is I'm just making a stream that succeeds with the user's ID, that send user ID, so that the user can, on the front end, can know what their ID is. All the votes, it's going to take this vote stream and wrap these in that send votes constructor. So it's just wrapping all of these different items into their that different command protocol, then turning them into JSON, then wrapping them in a WebSocket frame for text, and those get sent over. I'm also doing a ZStream from schedule of every 20 seconds. I am making a WebSocket ping because I don't think out of the box HTTP4S does the pings, which is necessary to keep the connection alive in most browsers. At least it didn't seem to do that when I first tried this, and I just kind of kept it. Maybe that's been added out of the box, I'm not sure. But okay, that's basically the interop. This is the controller or what have you. This is the routes file of interest. It really just gluing together the command sent from the client to this slide app service. And so what is this? So it's a trait. It's a trait that has a few properties. It has this receive function that will take a user ID and a client command, and then hopefully do something useful with it that will affect these streams and its internal state. And then we have these three streams for the slide state, the question state, and then a stream of votes that is going to get broadcast out. Then we have some accessor methods. These are kind of boilerplatey. I could generate this with ZIO macros. However, I'm using the pattern of not the old service module pattern, but the new one that I kind of spoke about at ZIO World, which is not really a pattern anymore. It's just a trait with an object. And in the current published version of ZIO, the accessible macro has not yet been updated for this pattern. I have done that work. It's just not out there. So I'm writing these by hand. And then I have a live layer for this slide app. So all the interesting stuff happens here in the slide app live, which is a case class that takes some properties. So there is a slide state ref, which is it's kind of like the var on the laminar side. It's basically an atomically mutable reference to some state. And so all we do in receive first at the top level receive, we see if the command is either an admin command or a user command, and then we call one of two versions. So if it's an admin command, they basically do the same thing. They switch over exhaustively the different states, and then they just kind of delegate to the slide state ref, calling update, using those same methods there, which are the same methods that we were able to use on the front end as well. Like if I go into next slide, we can see that it's being used simultaneously in slide app here, but also here when the user hits arrow right. But it's nice because we get to keep the same state type in sync on both the front end and the back end and call the same methods on it at the same time, which is kind of cool. So yeah, every time we receive a command from the user's WebSocket, we update our internal slide state ref. And then same with the question, except this uses the question state ref and it calls update. And then for the user command, it's basically the same thing, except the only difference is when we receive a vote here. So yeah, that's kind of how we receive commands. I guess the more interesting part is then how are these streams getting pushed out? The reason why there are these slide state streams etc. I mean, that's basically the trait, right? Slide state stream, question state stream, vote state stream. That's not handled internally. That's basically all handled in the constructor for the live implementation, which we're going to take a look at next. Just having these vals here is enough to satisfy the traits interface. So how does that happen? Well, that's all this stuff. So this function is what allows us to do this. In the next version of ZIO, you won't need to do this hub-like thing. It should just work like this. Sorry. But because Adam and I were trying to balance versions and get the most recent stuff, I had to kind of hackily re-implement it. And obviously, I did not succeed. But yeah. We can ignore that and just talk about how this works. So there's this thing called a subscription ref. And what a subscription ref is, it's very much like that laminar var thing, even though I'm sure probably more of you are familiar with refs than the laminar vars. So I can explain both of them at once, which is, so there's the subscription ref, which I've misspelled, subscription ref. And the idea is it's just like a normal ref. So it could be, let's just pretend it's just a ref of int. So if we have val ref equals ref of int, we should be able to say, ref set 10, 20, etc. 0. We can have a countdown, which is nice. And then we can call ref get, and we'll get the current value. Inside this will yield us a UIO of an int. So it's all, and these are all UIOs of unit, I believe. So that works as normal. However, it simultaneously has on it, actually the subscription ref, technically, in order to get the ref, you have to call subscription ref. It's a very simple wrapper. So it has .ref, which will get you the ref, but it also, which you can then call these methods on it, but it also has the subscription ref.changes, which yields a stream of, in this case, it would be int. So what subscription ref does is it basically gives you a mutable ref that you can modify, but it also gives you a stream of all the changes that you could then, use and broadcast out to different users. That's kind of the idea. With the most recent version, which is in master right now, this has been replaced with Adam's Z-Hub data structure, which allows you to broadcast those changes to many listeners. Otherwise, you basically have to do what I did down here, which is call this broadcast. You have to sort of do some manual housekeeping using this old version called broadcast dynamic, which instead of using a single queue, basically has a redundant queue per subscriber, which could also be a reason for things potentially exploding. Because if 100 people join, that's 100 queues per subscription ref, and then that potentially could be it. It's much better to have one shared queue than 100 queues, and definitely recommend looking at Adam's talk from ZIO World on that. That's out on YouTube on Z-Hub. It's very cool and very clever, and there's really nothing like it out there in any other library, and it will perfectly solve this problem very efficiently. However, as I mentioned, we're not quite using that right now. But that's basically how that's working. We're making these vars, and then we're just pulling out those two properties I talked about. For the slide state ref, we're pulling out the ref, and for the slide var, we're pulling out the changes. Questions var, getting the ref. I call these vars, should not say var, should say subscription ref or something, and then the changes. And so just by assigning this changes property to these different streams, that's enough to get it to work, because I've used that broadcast dynamic, which is going to broadcast these out to everyone. If I say use subscription ref, which is the old version, should have, I believe, the same interface. No, I have to say to managed here. But if this should restart, it's going to reload. The problem with this is that if I make these changes, we'll see that it takes a couple clicks for everyone to catch up. There's sort of a delay. And that's because by default, in the old version before Z-Hub, these are all consumers pulling off of a single stream. So they each got to sort of have to take their turn getting the newest slide state, which is obviously not what we want. We want to broadcast out everything, which is why you need to do that thing currently of having all of these queues redundantly, but I've sort of abstracted over that with this little hub-like thing, which will do that dynamic broadcast, which under the hood makes a separate queue per consumer, which is very nice. But that's kind of the high-level architecture. It's all of the logic is basically, all the real logic is in the case classes, and then everything else is really just serializing and deserializing this command ADT for the protocol, the communication protocol, which are then sort of interpreted in parallel into updating the same case classes redundantly. And I guess the last interesting bit is for, which I didn't talk about, which is the vote stream, and which is that I'm not using this same pattern here because I don't care about the current vote map right now. That is actually a to-do item, which is something we potentially could work on in this, is to, so when someone joins, you want to get the current votes. Right now, everyone has to be connected, and then these cast votes are going to be broadcast to every front-end person in chunks. So everyone's kind of keeping track of their own state. The problem with that being that there is no master state that can be sort of updated or sent out when someone joins, just like we can with these things. Could do that, but I haven't done that yet. But so what's happening here is we're making a bounded queue for these cast vote ID things, which are, just to remind everyone, just to basically represent a single user's vote on a specific topic. And then we create a stream from those. And then we get to use this grouped within operator, which is very cool, which is going to wait until there are either 100 votes or 300 milliseconds elapses. And then it's going to gather everything within every 300 milliseconds or 100 votes, whichever comes first, basically, and chunk those up and then broadcast those out to everyone, which is pretty cool. And broadcast dynamic, I believe in the new version of ZIO, is also going to use ZHub under the hood, but currently it's the multi-queue architecture, which is basically what every other effect system uses currently. So ZHub should make things a lot more efficient. Yeah, and that's kind of how that all works. So it's slightly different. It's not using this FRP style change var subscription ref thing. It's just using a queue, because all we want to do is take what we received and send it out. We have no care about the ref aspect currently, which is this idea of a current state. We just want to take what we get and broadcast it back out to everyone, essentially. We're just an echo server that whatever demultiplexes, sends it out to everyone. Yeah, so that's the architecture. That's a bit of a thing. Are there any questions? Meanwhile, I'll see if the slide app somehow magically has saved itself. I very much doubt it. Any questions, Adam?
Someone had a question about JSON encoding and decoding, so maybe we can briefly hit on ZIO JSON there. I know you.
Okay, sure, yeah, totally. What did it say?
Just can you explain about JSON encoding and decoding?
Yeah, of course. I'll say everything I can say about that, which is that, so yeah, we have these series of case classes representing the state that we care about in our app. This is very basic. It's just an int and then a map from int to int. And so in here, in the companion object, we have these encoders. In most cases, actually, like if I go to question states, I can just derive a codec for question state, and it works because it knows how to, a question is basically just a UUID, a string, and then the slide index thing, which is just two ints coupled together. So this is all derivable. These derived JSON codecs are using Magnolia under the hood, which is a very cool library that basically just at compile time introspects on the shape of case classes and can use that information to implement sort of dumb implementations that are sort of mechanical for certain type classes like encoders or decoders. So assuming there are some base definitions for like encoders for ints and strings and whatnot, which there are, then you can easily sort of mechanically make an encoder for a case class of two of those things that have encoders or decoders for them. Because all it's going to be is, taking the label, if you could access the label at compile time, taking the inductive definition, whatever the other encoder or decoder for the type that is represented there, and mushing those together into a map, right? To encode it, you take the label, then you encode the value with that other, with the types encoder, that inductive definition of the encoder, and then put it into a map. So that's the magic of derived JSON codec. Obviously that exists for all of the other JSON libraries, but I do like Magnolia. It's very fast and it's easy to work with as well. I made a video on that actually on YouTube. But that's how the actual derivation is going. The only difficulty is in order to encode a map, the only default codec, I mentioned you need sort of this base codecs to exist in order to derive it automatically. For the map, the only one that exists is a map from string to anything else with a codec. For a map, you need a field encoder, and the only one that exists out of the box is string. I'm not entirely sure why that is, but I've made one for ints just by contra mapping on the string encoder, calling toString and toInt option, getting or else 0 if there's an issue there, so that I can then get an int map codec, which is required for this slide state. But that's how I create the codecs, is just basically using derivation. And then the actual serialization is handled inside of this WebSocket on the client side. It's going to handle when I call ws.send, it's going to serialize this for me. And when I call ws.received, it's going to deserialize the expected command, received command type, which is this server command thing. And then so I just receive the command already serialized. So as long as there's a codec in the implicit scope, which there is because it's on the companion object for server command, then it's just going to work. On the server side of things, I need to do this a little more manually because the WebSocket API is slightly less batteries included here. So I have to actually match on the text frame and then call from JSON on that, saying what type I'm trying to parse it into. And because this is all in the shared library, I'm able to use admin commands on the back end and the front end. And ZIO JSON works for both Scala.js as well as regular old Scala. So it all compiles and you get to share the same state, the same codecs across everything. I hope that made sense. Feel free to follow up.
One more question. Do you use a message broker or persistence database to save the message in case of fatal error? I think that is a next step, actually probably a couple next steps away.
Yes, no, so far it's going to be to prevent all fatal errors from happening. But yeah, it does look like there is an issue. What does it say? It couldn't connect to, so no, the first problem is that everything exploded. So even if we persisted the messages, I would like to be able to handle them successfully first. But then again, with this particular app, it's kind of a transient thing. I don't know if we care about necessarily the long-term storage of messages because, you know, if you don't answer your question during the presentation, it's probably going to not matter much. Invalid state error, that's super weird. I don't know what that means. So clearly something horrible has happened. I might have screwed up a few things. I might not have maybe redeployed the most recent version of my front end. So that could be it as well. Thank you very much, everyone arriving around me. As we mentioned, informal, but my family is visiting. I love my family so much. And they can take care of the cat now. Perfect. So what is happening? Yeah, we can actually implement a round trip thing, at least locally. That could be interesting if there are no other questions, just to sort of get a sense of how to pipe something through. Because one thing that I did want to do, there are a few things that need to get done, but one thing is it would be nice for the admin or maybe for anyone just to see how many people are here, how many people have connected. So I could get a sense of how many people it took, how many licks it took before you bit the lollipop or whatever and the app exploded. So let us see what to do. Okay, so I'm going to start in this slides, my big mega view, which I could break out into separate views, but let's keep it here. Actually, rather, let's go to where we have all this slide state stuff. And I'm going to make a new case class called population stats, which is right now going to be sort of connected users int. So this is going to be the state. Right now, it's probably not even necessary to have a case class. We could just use an int, but just to sort of show the pattern that I've been using, we'll do this. So I'm going to make a companion object for this, and I'm going to make an implicit val codec, which is going to derive JSON codec.gen population stats. So now we have a codec for population stats. And now this is in the shared file, so we could use it on both the front end and the back end. Next, we're going to actually want to, because right now, that WebSocket server communicates in this sort of a root sealed trait, which is these commands, the server commands and whatnot. I'm going to have to add another case to this. So another branch, I'll say send population stats. And in here, I can just have population stats. So there's the server command, that's done. Same with I don't know why this file is called admin command. This should be called client command. And same with this. Actually, no, the client's not going to tell anyone anything. So the client command will not change. This is going to be sent by the server when someone connects or when they disconnect. And so on the slides app, we'll go to slides real quick. And actually, I will grab one of these windows to put it next to itself. Let's just do right at the very top, Zymposium. Next to this, we can have maybe inside of parentheses or something, the current stats. So I'm going to, where I have all these vars, where's the slide state var. So I'm going to make another var up here by the top. It's going to be called population stats var, which is going to be a var of the population stats. And I will just make population stats of, well, 1 is a good starting point because at least one person is going to be connected when they're on the website. So it's a good starting spot. And then I'm going to go back to this Zymposium header. And what I can do here is I could say child.text, and then I can bind in the current value of this population stats var. I'm going to get the signal out of this, which is a lot like that changes field on the subscription ref. It's going to be a signal of the changes to this var. So it's basically the same thing. And I'm going to just call toString on this. So it's going to be very ugly, or maybe I can just get out the connected user and then call toString. So we'll see, hopefully it will show up in just a moment once this is done. So there we go. We have 1-1. Not very beautiful, but that's not the point. So the idea is if now I were to join with a second user or something that this number would increment. Well, first things first, let's go to where we interpret the commands. So on received, we're going to now have to case match on this send population stats, which is quite simple to implement. We just take our population stats var and then set it to the one that we received from the server, which we're going to trust more than our sort of local redundant duplicate, which is just fine. So going to server, we can now, when the user connects, we can send them a stream. So I can say zstream succeed. Well, how should we do this? Let me think. So every time the user connects, we want to, send out, update this internal var. So I think we could do the same thing that we did previously. So I'm going to go to slide app. I'm going to make a population stats stream. Population stats stream. So there's a stream of population stats. What is happening? Let's see. Okay, so yeah, now I need to implement that here. So I'm going to implement population stats stream. And actually, what we could do instead of this is basically do the same pattern as we did before, which is just have this be a property up here, actually, because we're going to basically be able to get this for free from a subscription ref. So there's no real point in having a method there. It will just be something we're going to accept, and that will fulfill the interface. And then also, we're probably going to do that whole same pattern again, which is also accepting a population stats ref, which I could probably just change to be that subscription ref thing. But instead, I'm going to do this just to keep the same pattern that I had before. And now we need both of these properties. So basically, I'm going to copy this pattern and say population stats var for whatever reason, and then say population stats, and then make an empty one, which does that have a, okay, just a one. We'll probably do a dot empty thing, but this is fine for now. Actually, I'll say dot empty. If no one knew this, because this is fun, in IntelliJ, if you just type a method and then hit Alt Enter, you can say, create that method for me, please. And it will jump you to the right place where that method should be defined. And if it can interpret what type you want, it might also be able to do that for you based on context. So I'm going to say population stats empty, which is nice. And then I can go back to where I'm creating this over here, so that if I ever decide to give it a new default value, these can all be in sync, which is nice to have. And now I want to go back to my state app. So now I have a var, and now we need those last two properties, which is the population stats ref, which is simply going to be population stats var.ref, and then also the population stats stream, which is going to be the changes made to that ref over time. So everything type checks. And then what we want to do is, let's see. Yeah, so we could actually also, we could do a couple of things. A silly thing to do would just be to add some two methods to our thing, to our trait here, which would be, let's say, a user joined command, which could be a UIO of units, and a user left, user disconnected command. So now I can implement these, and it's going to be quite simple to do this. For user left, we could just take our population stats ref, call update, and then we can get the old stats, and we can make a new one. So stats dot, and this is where you might want to say add one or whatever. Very silly version. And I'll just copy ourselves, get our old connected users and add one to it. Connected users is equal to connected users plus one. And then I will say remove one, which will do the opposite. So very silly methods. So that should work. And then also same with this, user joined. Oh, this should actually be user remove one, and then add one. Okay, good. Kind of strange, but good. And then inside of our server implementation, we want to do a couple things. We want to add our new stream that we just made, which is going to be our population. What's it called? I probably named it incorrectly. Oh, I know the problem. I haven't yet made an accessor. I need to do this manually now. So it's called population stats stream. So I could just say population stats stream and stream and regenerate the type here to be a stream of population stats. And then I also want to basically do the same thing for whatever, what is it called? User joined and user left. So we can just call these user joined, access M, user joined, and then do user left, add the types. They should be, yeah, has slide app, nothing unit. Perfect. So now inside of this thing, I should be able to say in our server, I should be able to get the population stats stream, map it to a server command by saying server commands dot send population stats, which I think I'm importing everything. So I could just do that. Nope, import that, please. And then JSONify it and send it. And then what I want to do is two things. When the user disconnects, there's this onClose method, which I'm saying goodbye, but I can also say slide app dot user left. Obviously, it would be better to probably do this, like keep track of all the IDs or something. But this is just sort of a very hacky stream of consciousness first attempt at doing something like this. So we're going to on close, you have this option to run some effect on close. So we're going to say that the user left. And then on join, how do we do that? Well, we're actually returning an effect from this. So I can say slide app dot user joined, and then return my WebSocket builder. I believe that'll work, which is kind of silly, but it works just fine. So let me go back here and see what is not compiling. Well, first of all, I'm watching the logs, which is useless to me now. And then I should just be able to start my server, and hopefully it'll work. I mean, if it compiles, it should work, right? That'd be cool. I might be missing something. We'll see. Please. Okay, it compiled. So now there are 3 users, which doesn't make any sense. But actually, no, it does make sense because I have a bunch of tabs open. Aha! So if I make a new one, it should say 4 everywhere. Yay! Nice. So now the more I add to this, the more users I have. And then if I close them, it all updates immediately. So there we go, a user count. Huzzah! Oh, and I have 1 error too. So that's awesome. What did I do? Unchecked address already in use. Oh, so I am already somewhere. I have a connection open. Oh, in this other window, I think. Oh, look at that. Good, 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 good. So let me add user population logic and push that up to GitHub. And I will push that up to Heroku master. And maybe that'll probably won't work because of all the reasons from before. But if it does work, that would be cool. Maybe that would be a good opportunity to redeploy the server and have that try. But anyway, I've been going slightly crazy over here. So any questions? How's it going?
I think people are, so there was one question about laminar and how it handles the same value when you change the var. So like if you have the var that's set to 1, the next value is 1, does it actually emit that or does it not?
Oh, sorry. So in laminar side of things, we'll take a look. Slides. Let me get back my local host next to my thing, because this should actually, if we take a look, it should reload quite quickly. I have it set up to reload relatively fast. Zymposium. So if I make this, the normal spelling, let me see, is it? Oh, there we go. So Zymposium. It takes about a second to reload currently. Okay, cool. So that's reloading. So yeah, let's take a look at making something silly. This will be a div. And I can have inside of here a div that says silly thing. And we will just plop this. Actually, I will make this the view. And this will be view 2. So we'll just take a look at silly thing in isolation, hopefully. There we go, silly thing. So what we can have is a var. So I will make not a Scala var, but a laminar var. So account var, which will be a var of the number 0. And then what I can do is I can say child.text, and I think I can just say count var and pipe this into here. It should stringify it for me. We'll see if that works. Nope. I should say signal.map to string. So I'm getting a signal of, nope, there's another problem I've done. Oh, I've never, this is not in a div. Div. So that should work. We should see the number 0. Cool. And then what I could do is I could say something like window events dot on key down or something like that. I can get the key here, or I can actually map out the key value dot key, and then I can case match on, I think, arrow up. And what I can do here is I can say count var dot updated, and I can add 1 to it. I can also map on arrow down, do the same thing with minus. And hopefully, if this works correctly, and then also maybe an underscore so I don't get bugs, I can hit up and down, and it goes up and down. So the way this is working is this count var, it has a current value that you can get out, right? At any point, you can actually say count var. If you have a var, you could say .now and get the current value. But also inside of it is a signal of changes that is going to be emitted. So you can map over these signals. They're sort of just like streams in ZIO, a little different. These FRP, there's like a push-based versus pull-based architecture of these streams. You don't have to think about it much. ZIO streams is pull-based. FRP libraries tend to be push-based, which is generally better for front-end stuff, but you don't have things like back pressure out of the box automatically for you, which pull-based streams do. So generally for back-end, you have pull-based, and front-end, you have push-based. which is interesting. But yeah, you can map over these things. You can map, and then, I can map over it multiple times. I can map and multiply it by 3 or something. So even though the internal var is one thing, I can have another one that maps over it by 5. I can use the same signal multiple times and just bind it in multiple ways. So here I have 2 signals. Maybe I should separate these out into other divs so that we're not confused as to which one is which. So yeah, we have the internal value is probably, what is it? It's 4 right now, but you have different multiples of it, which is kind of cool. And some of the other silly things you could do, we could just say like, 1 to 20 dot map and get some kind of factor. Not sure if that's the right use of factor there, or multiple rather. And then I can just multiply it by some, I'll just call it x, to not think about anything. And then this is going to get interpreted into all these things. So now when I hit up or down, it's going to jump very quickly through all of these multiples of things, which is kind of cool. And I could even do x.toString, so we could see which multiple it is, and do a little arrow, an ugly arrow, and then take a look at that. So here are all the different multiples. So 15 times 14 is 210, hopefully. So that's kind of how laminar works. Very cool. The vars and the signals and the binding and the whatnot and the events. You just get all these events and you map them to different things. But it works really nicely with WebSockets because you can take these outgoing events, plug those streams into some other kind of stream, and then, yeah, you just need some kind of glue between the server and the client. But one can imagine a framework, I hope to work on it one day soon, that abstracts over most of that and just lets you sort of pretend that your front end and your back end are really all part of the same code base. Besides the glue code of the WebSockets, it kind of feels like that because of the sharing of all of the actual data classes. All you have to do is a little bit of manual encoding and decoding. It's kind of very cool to be able to share everything. I am very excited about the possibility of it not exploding and being very performant. I've got to figure out what the problem is by sending chunks of votes. And that's sort of like semi-event sourced model where you can just send the delta, broadcast out a delta instead of some large state. And due to the fact that you get to use the same logic and the same case class and the same code on the front and the back end and the front end can in parallel process those diffs and end up at the same state. It's kind of the idea of, I guess, CRDTs, except this is not like super distributed fault tolerant. It's a simpler version that has it's just really just event sourcing.
I have a feeling we'll get that working later this afternoon.
Yes. Yes, I hope so. I hope, yeah, man, next week, stay tuned. So I hope this is like, it seems cool. I really wanted to actually work with 100 people and 1,000 people, and I know it's possible. Yeah, I kind of just, I didn't test this, so it's my fault, but it's the real world. We promised you informality, so here you go. A semi-broken app. One day.
Sounds like people will just have to come back for more next week.
Yes, I think that's right, Adam. I think that's right. Yes, thank you for well, there are probably more questions, and we don't have to.
There are like 2 more questions maybe we can quickly hit on, and we can also like cover all this stuff in more detail next week. But there's one question about how you manage to achieve such quick turnaround with Scala.js, and there's another one about where you define CSS styles, if you want to do that.
Yeah. So I'm guessing the quick turnaround, I mean like the fast reloading when I make a change, have it update automatically?
I think so. Or
I'm going to assume that's the case. So I actually copied a starter library by the same person who made Laminext. I think his name is Eurek. I might not be pronouncing that correctly, but I'll try to find and post. I will push up this this repo later for whatever it is onto GitHub. It's already on GitHub. We'll make it public, and then I will add to the README the links to these things. He has a starter library, a Gitter 8, I think. Actually, I'm not sure if it is a Gitter 8, that uses something that I've never heard before called Vite. No idea. It's like a Webpack thing that's simpler. There are always new build pipelines for JavaScript. This one, though, however, seems to be faster than using Webpack's dev server. So when it's a very simple app, it seems to reload in like half a second, which is really good. I had some problems with it, but it's always a bit of a hack fest to try to get fast reloading. But generally, that's it. On Scala.js itself has something called fast. What is it? So if I go frontend.fastLink.js, every time this little tilde, that's an SBT command, it'll rerun this every time there's a change to any file in this package. So it's going to watch and then relink everything. Basically, it's going to emit a main.js file, which is then can be used with any build system, including apparently Vite. So this is going to look for some index.html file. And then this itself links to that front-end target Scala 213 front-end fast.op main.js file. And Vite is going to notice now that when this file changes, it's going to reload it. So it's kind of hacking. There is no full solution system yet. I really want to work on something like that. I think that would be really cool. I think there's a big opportunity. I think Scala.js is freaking amazing. And the big problem with it is that, yeah, there's a lot of do-it-yourself type stuff on the front end. I think many Scala programmers probably never thought of doing front-end stuff. It's kind of like a back-end centric language, right, with Spark and everything. So, but I think there's a huge opportunity, and it can be really fun. Front-ends is not fun because of how shitty JavaScript is, I think. I think that's why a lot of people have bad impressions of it. So yeah, that's how I'm doing hot reloading, is Vite, whatever the heck that is. But it works. I've gotten this to work with Webpack as well. It's just it was slightly slower. So I like it faster. I want there to be 0 wait time. I think it can be even faster than this using some settings. But yeah, it's all right. 1 second is acceptable. With CSS though, that's also handled by Vite. And this actually happens very quickly. They basically just re-inject, so I could change the background color and it should happen, if I don't screw up, it should happen basically immediately. So if I say red important, there we go. Okay, maybe it's not immediately, but it actually doesn't even have to reload the web page. It just re-injects the CSS file, which is pretty cool. Yeah, but that's that. Yeah.
All right. Well, I think we've probably taken enough of folks' time for the day, but thank you so much, everyone, for joining us. This was at least fantastic for me. Hopefully it was fantastic for you.
Yeah, thank you so much. That was very fun. Next time I will make sure to pet my cat for 3 hours directly before broadcasting. Or synchronize better with my girlfriend.
Schedule when the girlfriend is home.
yeah, that might be the solution. But yeah, thanks so much everybody for sticking around. And you could post more questions in the thing, and we'll.
Yeah, please follow up on Discord. Yeah, that's a great forum for between these. Both questions about this, but really about anything Scala, ZIO, functional programming. Yeah, come Discord.
Yeah, and we might continue with this next week. Probably will, because we want to get it to work. But maybe we can go anywhere. It's anything you want. Looking forward to doing this more often. And thanks so much, Adam.
It was great.
Okay.
Yeah, thanks for putting this. This was awesome. All right,
Take care, everybody.